Example 8 is the last example I will show you in this section, okay? We are going to establish the identity 1 minus the sine of theta over the cosine of theta is equal to the cosine of theta over the quantity 1 plus the sine of theta, okay? Before I do this problem, okay, I want to be clear, okay? When it comes time to have a test over this material, okay, remember you're going to have section 3.3 on there as well. And that was solving equations, okay? So you need to pay attention to the directions. When you see the directions establish the identity, that means what follows is an identity. This equation is true no matter what the value of theta is. So it doesn't make sense to solve for theta because it's going to work for every theta value, okay? So instead, if you are given a conditional equation where the equation is only true for certain values of the angle or whatever variable you're using, then it makes sense to solve for the variable, okay? So make sure you pay attention to whether or not you're establishing an identity or you're solving an equation, okay? All right, so again, if you see something like this, because it's an identity, you can't just cross multiply here and solve for theta. That's not what you're doing, okay? You're simply starting with one side of the equation. You're using basic trigonometric identities plus algebraic manipulation in order to achieve the other side of the equation, okay? All right, so let's start here. Okay, we've got one fraction equal to another, okay? So, they're both about the same complexity. So which side should you start with, okay? Well, if you started with the left side, just kind of think about what's going to happen, okay? You've got a single fraction here, but the bottom is just a single term, so you can easily break that fraction up into two fractions. You would get 1 over the cosine of theta minus sine theta over the cosine of theta, and then that's going to turn into the secant of theta minus the tangent of theta, okay? That is not what you're trying to get, okay? That doesn't even come close to the right side of this equation, okay? So what we're going to do here, okay, is we are going to start with the right side of the identity, okay? So we're going to pick cosine of theta over 1 plus the sine of theta. We're going to use basic trig functions and algebraic manipulation, and we're going to hopefully end up with the left side, which is 1 minus the sine of theta over the cosine of theta, okay? All right, so this is a single fraction. If you try to break it up, okay, you are allowed to take every term in the top, divide by the entire denominator, so this fraction doesn't even break down, okay? So remember the trick we did in the last example, in example 7, multiply by the conjugate, okay? So I am going to rewrite the fraction before I multiply by the conjugate. Okay, so we are going to multiply top and bottom here by the conjugate, okay? The conjugate of 1 plus sine theta, because it has two terms, okay? So we're going to keep the same term on the left, which is a 1. We're going to keep the same term on the right, which is sine of theta. And then you're just going to change the middle sign. Instead of a plus, we're going to write down a minus, okay? That is the conjugate. You have to multiply the top and the bottom by the conjugate, okay? You can't just multiply either the top or just the bottom. It has to be top and bottom because 1 minus sine of theta over 1 minus sine of theta, that fraction simplifies to be 1 because you're just dividing a quantity by itself. So you're really taking the original fraction cosine of theta over 1 plus the sine of theta, and you're multiplying it by 1. You are not allowed to change the original fraction. So that's why you have to multiply by a quantity equivalent to 1. Okay, all right, so let's see where this conjugate takes us, okay? We are now multiplying fractions. So we are going to multiply across the top and multiply across the bottom, okay? So we can take the cosine of theta, we need to multiply it by 1 minus the sine of theta. 1 minus the sine of theta has to be in parentheses because it has two terms. It is a package deal. You are going to have to come back and distribute that cosine potentially, okay? The bottom, you're going to multiply the package deal 1 plus the sine of theta times the package deal 1 minus the sine of theta. okay? They must be in parentheses because you're going to have to distribute, okay? All right, so let's keep going here. I am going to multiply out the top, okay? So I am going to distribute the cosine of theta to the 1 and then to the minus the minus sine of theta. So this is going to be cosine theta times 1 is cosine theta minus cosine theta times sine theta, okay? The bottom, if we FOIL this out, okay, hopefully you've done enough practice with this. This is going to be first terms, 1 times 1 is 1, and then you multiply the outer terms. 1 times negative sine theta is minus sine theta. Then the inner terms, sine of theta times 1 is going to be plus sine theta. And then the last term, sine theta times negative sine theta, that's going to be minus sine squared theta, okay? And then this is very, very similar to the last example, okay? In the bottom, you're going to see that there's a negative sine theta. It cancels with a positive sine theta. So in the numerator, you're left with cosine of theta minus cosine of theta times the sine of theta. The bottom, you have 1 minus sine squared of theta, okay? And then we know from the Pythagorean identity that the denominator will just be cosine squared of theta, okay? Since sine squared of theta plus the cosine squared of theta is equal to 1, okay? The top has cosine of theta minus the cosine of theta times the sine of theta, okay? So now would be a great time to go back and check to see what we're trying to get, okay? So if we go back up here, remember we started with the right side, so this is what we're trying to achieve. 1 minus the sine of theta over the cosine of theta, okay? At where we are right now, we have a cosine squared in the bottom instead of just a cosine, and we also have cosines present in the numerator, and we shouldn't, okay? But if you notice, every term in the numerator has a cosine of theta, so we can factor that out. If we factor out a cosine, that's going to leave us with 1 minus the sine of theta. And you can check yourself by multiplying back out to make sure you factored correctly. Cosine theta times 1 is cosine theta, and then minus cosine of theta times the sine of theta, okay? So you multiply it back out, you can check to see if you factored correctly, okay? So that's what the numerator looks like if you factor out a cosine theta. The bottom, cosine squared theta is the same thing as cosine of theta times the cosine of theta. You don't have to write that out, but if you need to see it, go ahead and do it, okay? So now it becomes clear that there's a cosine theta in the top that cancels with one of them in the bottom. And then that is going to leave you with 1 minus sine of theta in the numerator and cosine of theta in the denominator, okay? That is the left side of the identity. We achieved it, and so we have verified this identity.